the Bitcoin white paper got published. And soon after that, the network itself got started. So Bitcoin is the first example of decentralized money or decentralized currency. And what does that actually mean? What's the big deal about it? So that's the first time in human history, basically, that we have money that belongs to everyone. So it's not controlled by any sort of central authority. It's not issued by any central authority like a central bank or any other entity. It's basically owned and controlled by people. So people are spinning up nodes around the world. When Bitcoin was introduced, everyone was allowed to launch their node to start validating transactions. And in return for validation of those transactions, they get tokens. So if you're a Bitcoin miner, just download Bitcoin software from the internet, you start running it at your home. And basically for every set of transactions that you help validate or secure, you're receiving Bitcoins basically as a reward for your contribution to the network. So practically it's a digital asset, it's a digital money that is owned by everyone. And that's, I believe, very, very cool and the first implementation of that kind in human history. The second interesting feature is that it's accessible to everyone. So it's digitally native, it's internet native. So by default, you just need internet connection and Bitcoin wallet, and you can actually access the money and use it. So these are two very interesting properties that we never have had in the history of mankind, and it really caused a lot of interest all over the world, and that's how the whole movement started, I guess. Once people understood the significance, the importance of Bitcoin and the revolution behind it, people started asking, are currencies basically just the first use case of this new industry? So why can't we, in a similar manner, decentralize social media? Why can't we decentralize all other financial applications? Why can't we do the same games, for example, ride-sharing services like Uber? So basically, people started, thinking about these things and how we actually decentralize everything, so to say. The issue with that, it sounds great in theory to have, for example, social media that belongs to everyone. So when you post something on that decentralized social media, you're basically a co-owner. For your posts, you're getting tokens back, and basically you can say it's sort of capitalism done right in some way. So everyone's the owner. It's not like only the founder has 100% of the company that he started, and users are putting effort, putting in time, but they're not getting anything in return. So in that sense, these decentralized applications are I would say, way more fair. And it seems like a very, very interesting future if you manage to pull this off. The first challenge that the community or the industry faced in this phase was that each of these applications was required to have its own blockchain. So Bitcoin has its own blockchain. If you want to start some decentralized media now, it needs its own blockchain. If you want to start decentralized ride-sharing service, it needs its own blockchain. Building and launching and running a blockchain is not a trivial task. It's basically decentralized computer system, and it's not really trivial to kind of launch and maintain and decentralize. So it's a huge effort. I would say that takes at least 1 year. And as an application builder, you want to focus on your application, not on building this underlying infrastructure, ideally. So that was a huge kind of obstacle to wider adoption or exploration of these very interesting ideas. So how did he approach it? What was the solution for that challenge? It was Ethereum. So how many of you know about Ethereum? Just wondering. Okay, almost everyone. So Ethereum, for those who don't know, is the first programmable blockchain. So Ethereum, you can think of Bitcoin as a calculator. So it's a single app machine, so to say, single app network. It just has one single asset, which is Bitcoin, and it can move it around. I can send you 2 Bitcoins, 2 Bitcoins to him, and that's all Bitcoin does. Ethereum is very different in a way that it has its own Turing complete virtual machine. So how many of you know what virtual machine is? Okay, awesome. So it has a generic Turing complete virtual machine that anyone can use, and it has programming languages like Solidity that are targeting that virtual machine. And now everyone can just simply program their application and deploy to Ethereum. So all this hassle of launching your own blockchain, bootstrapping, decentralizing is going away. So basically you just program your application, deploy it to Ethereum, and it magically works. So it basically removed all the hassle of building and launching your own blockchain, and it was a huge step forward. So then application builders were able to focus on basically what they need to do on improving their application, bringing it to the world, focusing their communities, etc. So it was a huge step forward. And as I said, if you can think of Bitcoin like a calculator, like single app machine, you can think of Ethereum as a smartphone where you can actually just deploy your application or install your application and it works. So as I said, it was a huge step forward, but it wouldn't be that interesting if there wasn't more challenges. So the next challenge that we as an industry faced is that Bitcoin cannot scale. Bitcoin network can process 10 to 15 transactions per second, which is orders of magnitude less basically than what we actually need if you want to build all these interesting applications, decentralize the world. It's orders of magnitude less than what we need. To make the matter worse, you cannot really scale decentralized blockchains like Ethereum. The issue is that you have a lot of nodes, thousands of nodes in this network, and they need to reach consensus on every block of transactions. So, you have thousands of nodes across the world. They need to exchange normally few messages to agree on every batch of transactions. There is this latency, like half a second to send the message from New York to China, whatever. So it takes time. And you cannot really do a lot about this throughput if the blockchain is as decentralized like Ethereum. You can maybe take it to 100 TPS transactions per second, or maybe 200, but it's still far, far from enough if we want to build this decentralized future, kind of. So what was the solution? What the industry came up with are layer twos, so-called layer twos. So layer twos are blockchains that are built on top of Ethereum. So it's like a execution layer built on top or around Ethereum. So you can think of Ethereum being in the center and all these layer twos around it. And there can be practically infinite number of these layer twos. And these layer twos are blockchains that don't have to be that decentralized, that they can have smaller number of nodes, and thus they can have higher throughput. So let's say a single layer two can have 1,000 transactions per second or 2,000 transactions per second, and you can have, let's say, 100 or 200 layer twos on top of Ethereum, and that actually scales a lot. That can probably give us the level of scale that we need. On top of, I don't want to go too deep into the matter, but on top of layer twos, you can also build layer threes. So you can build additional blockchains on top of these blockchains, and then you have sort of quadratic scaling, which can give you practically millions of transactions per second. And that is probably very much enough for this decentralized future and to onboard the world, so to say, to this decentralized future. So it's a great solution. And the reason these layer twos don't need that level of decentralization is because they normally inherit security from Ethereum in some way. There are certain techniques like ZK proofs, optimistic proofs, and several other techniques that these layer twos actually use to leverage security of Ethereum in some way. So that's why they don't need to be that decentralized and still can maintain security. So layer twos are a great concept, but again, there's a challenge. The challenge is that with this, if you remember in the beginning when I was talking and mentioned that it's hard for every application to have its own blockchain. We're kind of back to square one because now applications would practically have to build their own layer twos. And will every application build its own layer two? Building a layer two is, again, not a trivial task. These techniques that I was mentioning for deriving security are pretty hard to implement. These zero knowledge proofs, it's like kind of like complex cryptography, and application developers really shouldn't know these things. Like when you're building a Web2 startup today, you don't think, how underlying infrastructure works, how AWS works. You just build your application and you work on it. So that's how it should be, ideally, in Web3. People shouldn't understand how all this complex solution works. So what to do about it? The solution, at least the way we see it, and at least the way we believe, is Polygon, the project we started. So Polygon is a scaling platform. It is a suite of these layer 2s, of these scaling solutions, or as some people call us, layer 2 aggregator. So what's convenient about Polygon is that it offers scaling solutions or layer 2s out of the box. So you as an application developer, like with Ethereum, it's very similar to Ethereum, but it's just much more scalable. You just come, you pick your favorite scaling solution, you deploy your application to it, and it magically works. So we're kind of back to that developer experience that we ideally want. So it gives you these layer 2 solutions out of the box, which is very convenient. And the second important thing I would mention is that if you're building on Polygon, you are basically assured that you're always on the bleeding edge of technology. So crypto and Web3 is a new technology that is developing rapidly. And as application developer, you shouldn't really, keep track of all the bleeding edge technologies and advancements in the technology itself. And we are, as a project, committing significant resources. Most of our resources are basically committed to exploring these new solutions and to offering them to developers. So we are doing that instead of developers themselves. So these are, I would say, two major advantages of Polygon itself. And we see it, and a lot of people see it as this third important kind of milestone or evolution of the industry itself. So it started with Bitcoin, with single application, continued with Ethereum, with programmable, basically, blockchain that anyone can use. And the final stage, or at least the stage that we're in currently, is Polygon. It's programmable platform that anyone can use, programmable and scalable platform that anyone can use to realize their Web3 dreams, so to say. So that's where we are at the moment, and turned out it was actually a good idea. So Polygon today is the leading scaling platform in the world. We have more than 100 million user wallets. Wallets are basically accounts. I don't know how many of you know what crypto wallets are. Okay, awesome. So more than 140 million user wallets. We processed as a platform more than 2 billion transactions, and we have roughly 40,000 applications deployed. So we're very happy with the progress so far and where we are at this point. In terms of applications, Polygon hosts really a wide variety of applications. So basically all major Ethereum or Web3 native applications, like Uniswap, OpenSea. How many of you guys know about Uniswap? Okay, awesome. And OpenSea, the NFT marketplace. Okay, perfect. So OpenSea, Uniswap, Curve, basically all the major Ethereum applications also migrated to Polygon as well. On top of it, yeah, I guess we should pay attention to this. On top of it, big Web2 applications and companies like Facebook, Instagram, Stripe, and others are already on board. And even big, large enterprises and traditional companies like Starbucks that we announced like a week ago, Coca-Cola, Adidas, Salesforce, and many, many others are already using Polygon. So we're really happy to see that level of adoption, and that Polygon has actually found very strong product market fit at this point. You remember that I mentioned that if you build with Polygon, that you're always on the bleeding edge in terms of technology. So we can just briefly talk about what is bleeding edge nowadays, what is the hot thing at the moment. And I would say that is Polygon ZK VM. So I'm just wondering first, how many of you know about ZK cryptography? Okay, quite a lot. But for those who don't know, ZK is I would say, fascinating field of cryptography. It's a family of cryptographic techniques and methods that have some very interesting properties. So it's called zero knowledge because you can prove any sort of statement without actually revealing the statement. It sounds, of course, a little bit counterintuitive that you can actually not reveal what the statement is, but I can undoubtedly and mathematically prove to you that the statement is correct. So how do we use it for scaling? It is very convenient that the output of any ZK cryptography operation is a ZK proof, what we call ZK proof. So let's say you have 1 million transactions on a blockchain, and you put it through this ZK algorithm, so to say, or set of algorithms, and the output on the other side is a small single proof. And you just verify that proof, and it's very quick to verify normally even on blockchains. And you actually verify that all these 1 million transactions were correct. So that's super convenient for scaling. So in layer 2s, basically, we can process, let's say, 1 million, 2 million transactions, and then we submit a single proof to Ethereum, that's ZK proof. You remember that I was saying that layer 2s inherit security from Ethereum. So let's say we process 1 million transactions in layer 2. We create a zero knowledge proof. We submit it to Ethereum. It gets verified there. And we inherited the security of Ethereum by just verifying that single small proof. So it's very convenient. It literally, it took us to a next level in terms of the transaction throughput that we can actually support. So it's like very interesting, very advanced field of cryptography. How many of you know about EVM? Okay, about half. So EVM is the core component of Ethereum. You remember that I was mentioning this virtual machine of Ethereum. That's EVM. It's Ethereum virtual machine. That's the core component that is processing, interpreting, and processing transactions of Ethereum. So once you have that core component implemented in your layer 2, you fully inherit the whole developer experience of Ethereum. I'm going to explain in a moment why is that important. But now that we know what ZK is and what EVM is, so we kind of combine these two into one product, which we consider, or the whole community basically considers, the holy grail of scaling. And the holy grail of scaling, or the gold standard of scaling, means that it has three very important properties simultaneously. One, it scales, as I explained. So you can just process 1 million transactions, generate a single proof for it, submit to Ethereum, it gets verified on Ethereum. So that's sorted, that's great. The second property is that it maintains security. As I was saying, like once that ZK proof gets verified on Ethereum, you fully inherited the security of Ethereum, which is the most decentralized blockchain in the world at the moment. So it's also very secure. And the third very important option, and that's why I mentioned the developer experience, is that it completely maintains developer experience of Ethereum. So Ethereum is a very mature ecosystem. As a developer, you don't only need the blockchain, you need programming language. So Ethereum has Solidity, which is very mature, very popular programming language that many developers already use. It has developer tools for contract deployments, wallets, a lot of this auxiliary infrastructure that is really required if you want to have a mature ecosystem. So Ethereum has all of that, and developers are used to using that. So if you want to introduce a layer 2 that uses different programming language, you will have to build all the tools from scratch. People will have to learn that new programming language. That would cause huge amount of friction for adoption, basically. In this way, with ZK-EVM that we implemented, you fully inherit the Ethereum development ecosystem. So people use Solidity the same way like they use on Ethereum. They use the same tooling to deploy their applications. So everything works the way they're used to, developers are used to. So that's basically the first time that anyone shipped, basically delivered ZK-EVM, and we're very happy that we are the ones, so to say. And yeah, it took us a little bit more than 1 year of heavy development and research, but ZK-EVM today is the reality, and we will release the mainnet in roughly 3 months from now. So we are very excited about that, and that's, I believe, one of the coolest and bleeding edge technologies at the moment in the industry. And I would like to finish, this is the last slide. I would like to finish basically by trying to explain once again, or explain more clearly, what is the point of all of this? What are we trying to do? What is the vision behind this technological movement? So we believe the purpose or the grand promise or vision of Web3 and crypto is to create the network of value. So with the internet, we created this global permissionless network of information, right? Which changed the world in profound ways, I would say. So before the internet, the access to information was definitely not democratized. Information were, often reserved for the privileged ones. So, and now with the internet, anyone in any remote village in Africa or Kazakhstan or wherever, they can attend MIT courses, for example. It's accessible to everyone. So it's really, of course, important innovation that democratized access to information. What we are lacking currently is that permissionless network of value, like the same thing, but for value, for global economy. Like that person in Kazakhstan can now learn to code on one of the MIT courses, but they cannot monetize knowledge. Or for example, I used to live in Africa for some time, and in Tanzania specifically, it's a big country, and 1/3 of the population doesn't even have IDs, not to mention bank accounts. And how can these people now monetize their knowledge? Let's say they learn to code or learn some other skill, how they can monetize it. With crypto, with this global network of value that we're trying to establish, all they need is a mobile phone. They just need a mobile crypto wallet, and they can actually start working for a company. They can start working for Polygon, for example, and they get paid with crypto. So basically it democratizes access to value or transfer of value, or it gives participation, gives the right everyone to participate in, so to say, global economy. So to put it another way, we actually dream or we envision this borderless global economy that should kind of take us to some new, hopefully better world. So in this new better world and this new economy are, as I said, more accessible or more inclusive. Really, anyone in the world who has internet connection can participate. That's one thing. The second thing is that it's more efficient. So compared to current economy, which is basically bottom-up based, where you have intermediaries, banks that communicate with the other banks, and it's like very kind of inefficient system that got built over the decades and even centuries, and it normally has working hours. Stock markets close at 5 p.m. and this new economy is internet native. It's working 24/7, and it's very, very efficient because it's, again, internet native. You don't need any intermediaries. Everything is point to point. So it's much more accessible and fair, I would say, more efficient and yeah, more fair in the end. So as I was saying, like all the projects or the applications in this new economy are basically owned by people. So for example, Polygon, we as founders, normally founders of Web2 startups, they have 100% of the company they started. In Polygon, as the founders, each of us has 4 to 5% of the total token supply, which we believe is much more fair approach to build projects in general. And people are kind of resonating with that very well, and that's why Polygon, for example, grew so rapidly, because people, I think, recognize that it's a more fair way to build networks and build projects. So I think it's definitely more fair, and it actually gives it kind of like unfair advantage, in my opinion, over traditional businesses and traditional startups. And that's why we believe that very quickly crypto projects or Web3 projects are actually going to disrupt traditional companies and traditional startups. So we're very excited. This is the vision that we believe in. We're very excited that we're able to work on it and bring us all a little bit closer to it. So yeah, that will be it. Thank you so much. And I'm here for any questions. Yeah, go ahead, please. I can see that you know about some of our products, so thank you so much for that. So you can think of it as a set of tools. As I was saying, Polygon is a suite of solutions. So all these solutions have different purposes. So I didn't want to go too deep, but data availability can be combined with ZK rollups. Then you need even less decentralization. Then you can even have one single node combined with data availability from Avail as zero knowledge proofs on Ethereum, and that can really scale. That can maybe process 10,000 transactions per second. So these are just kind of like a different components of this Web3 stack that Polygon is building and offering kind of out of the box. So I hope that answers your question. Thank you. Anyone else? Yeah, go ahead. That's a great question. That's a good thing. So if you maybe remember, I was saying that there are several different techniques how you can derive security from Ethereum. And one of them are these ZK proofs that we are as a project focusing on. The other one is, for example, are these fraud proofs. So for example, in fraud proofs, it's a type of reactive security, which means basically that transactions get processed. And if there is something malicious, some third party, someone who is observing the chain should submit what we call fraud proofs, or just challenge basically this malicious transaction. And then the operator or blockchain that produced it will get penalized. So that's how it works. But we prefer actually this way of scaling using ZK cryptography because it's a sort of proactive security. What does it mean practically? The transactions themselves cannot be even submitted to Ethereum if they're not correct. So to generate this ZK proof that you're submitting to Ethereum, all transactions have to be valid. Otherwise, you cannot generate the proof. So that's a very convenient feature. This reactive security means that someone has to observe the chain, then submit the challenge, and there's this challenging process. With ZK, it can't even happen. So the malicious transaction, you cannot generate a proof for a malicious transaction. It's mathematically impossible. So that's a very convenient property, and that's one of the reasons why we're actually betting on this zero knowledge cryptography. That's a great question. Thank you. Okay. Yes. That's a great question. But I would like if someone from ZK Sync was here, so we can actually discuss that in a fair manner. But ZK Sync announced testnet, but it's closed source, and we never saw the prover. We don't know, and the prover is not working. It's a testnet without a prover, so we don't know anything about that technology. They're being kind of secretive, but like if you compare the sheer strength of our cryptography team and their team, our team is definitely much stronger. So I don't want to speak about competitors. I would rather if they were here. But yeah, it's a testnet without a prover, which is the whole point of the testnet. So we'll see what they will. We don't know a lot about their work. Sorry? Polygon ZKVM, at least 3 months. So we need to go through several audits and community review and all of that. But also, it's always a race against the time to release something. But it doesn't mean a lot, like whether Polygon releases 2 months before or ZK Sync releases 2 months before. What matters more is the actual performance. Does the technology work? What's the throughput? How many transactions per second you can process? What is safer? There are, a lot of parameters there to judge actually who delivered better or earlier, so to say. You can deliver something with bugs 2 months earlier, but is that really a point? And yeah, I think it's basically regarding ZK Sync. Like they're announcing, they're saying they're going to announce a mainnet in 30 days, but everything is closed source. We're not seeing anything. It's kind of irresponsible. The standard model in blockchains is that you have open source code, people can review it at least for several months to look for bugs and everything. So yeah, they're taking a little bit different approach. I'm not sure it's the best one. Yeah, go ahead.
What kind of testnet do you support? Because I'm thinking course on blockchain and cryptocurrency. A lot of my students want to use testnet some very stack to try to create their own application.
Okay, thanks for the question. We are always publicly communicating all our testnet and mainnet releases. So I would invite even your students to participate. Currently, we have a private testnet, which is whitelisted and all of that. In roughly 2 weeks, we are launching a public testnet where everyone, including your students, will be able to try it out, to deploy applications, to submit transactions to the network and see how it actually works. So roughly 2 weeks from now, 2 to 3 weeks, roughly. We're targeting, actually, this is kind of like an alpha leak, what we say in Web3. We're targeting actually DevCon conference in Bogota, in Colombia, one of the biggest crypto conferences. The dates are 11th to 14th of October. That's when we're targeting to actually announce the public testnet. So I said, everyone, including your students, will be able to use it. And after that, we are planning the mainnet launch, the actual network launch, somewhere around the end of year. Yeah, thank you. Go ahead, please. That's a great question. I'm not sure, maybe for some times. I'm trying to think of applications that actually could benefit from deploying to Ethereum first. Maybe some applications that require high level of liquidity, some DeFi applications, but you know, DeFi, decentralized finance. But even on Polygon now, we have more than 5 billion, I believe, at this point of liquidity in Polygon POS chain. I'm really trying to think of some application that could actually benefit from deploying to Ethereum first, but nothing comes to mind, to be honest, because it's exponentially more expensive to deploy. You need maybe $200 or whatever, $100, and transaction fees are exponentially higher on Ethereum. So I'm not sure. There might be some cases where actually application can benefit from deploying to Ethereum first, but I can't think of any at the moment. Thanks. Go ahead. Of course, that's a great question. So just a quick side note. So these three ZK projects of Polygon, they're kind of converging now. We wanted kind of plurality or diversity of opinions, of approaches. That's why we supported three. We actually have four. The fourth one is with Ernst Young. We have Polygon Nightfall project, which is also ZK based. So we wanted different opinions, different approaches, because this is a very early stage of the industry. It's kind of like dial-up phase of Web3. You know, have you heard about these dial-up modems back in the days? Yeah, I think you're too young to use that, but your professor would know. It's in the early days of the internet. When I was young, in the 90s, basically end of 90s, we used to have these dial-up modems, and it was like incredibly slow and clunky technology that used to block your phone line. So you were accessing internet over the phone line, and you have this dial-up modem, and then it takes you like 10 minutes to open your email, to check your email, and you couldn't even think of like video streaming, something like YouTube. It was like unimaginable, and that shows how quickly the technology can progress. And similarly in crypto, you know, we have Ethereum that is incredibly low and user experience is very bad, and all of that. So it's kind of like dial-up phase. And today we don't even think we have lightning fast internet on our devices. We access it very easily. So that's where we believe the industry will be in, let's say, 5 to 10 years from now. But to answer your question, like these projects are now converging around Polygon ZK EVM, and they're slowly going to become, they're already becoming one team, basically. We wanted initially different opinions, different approaches, but they are closely collaborate and they're converging now into one team. That being said, What was your original question? How you? Fragmentation of liquidity. Fragmentation. Okay. So we believe with DeFi applications, fragmentation is a real concern. So we believe DeFi applications will also converge toward one chain, like Polygon POS chain, that we're actually upgrading with ZKVM. We're planning to upgrade Polygon POS chain to become secured by ZK. And the target, we target roughly 12 months from now to do that. And we believe that that chain, Polygon POS, will remain the hub for DeFi. We believe DeFi applications will normally reside there. And these other applications like Web3 games, Web3 social media, all these other applications, they don't necessarily have a problem with fragmented liquidity. They don't even normally need high levels of liquidity. So that's how we believe how it's gonna play out. That's how you're thinking about it. Thank you. Go ahead, please.
Yeah, I'm curious if you guys would like to share in terms of verifying it's not being as successful as getting the state transition. In that case, there's like scalability gains within the same amount of time they don't verify state transition. I'm curious if you guys have any notion of what that scalability gain looks like, verifying the
Yes, that's a great question. So we're constantly, of course, measuring, doing benchmarks for every iteration of ZKVM. So there are several times, so to say, or metrics that you need to take into account there. One is native execution, as you said. So we need to understand, okay, how much time it takes to natively execute these transactions. Then proof generation time, how much time it takes to generate proof for these transactions, and the verification time itself, how much actually time it takes to verify the proof. So native execution is native execution. You just need to go transaction by transaction and execute. Proof generation times in zero knowledge cryptography are way bigger than native execution. So that's the kind of the downside of ZK proofs, that you need to put huge amount of computation, much bigger than the native execution itself. But the good thing is that you only need to do it once. You only need one server, one entity needs to generate this proof, and then verification times are normally very, very fast. It depends on the family of cryptography, but normally they're very, very fast.
Yeah, I know like some operators. Like auditing doesn't really accomplish that. Like over stuff, like errors, definitely strategies like verification. What's that like timeline?
Yeah, great question. Again, like, as you said, XORs and some operations are kind of notoriously hard to prove itself, but to verify, they're very fast. Proof verification, once you generate the proof, at least in family of ZK primitives that we use, verification time is constant almost, or it grows logarithmically or quasi-logarithmically. So if it takes 0.1 second to verify 10 transactions, in the worst case, to verify 1 million transactions, it takes, let's say, 0.3 seconds. So the verification time is really short. We're very happy with the results there. And mobile verification is definitely something that we're looking into, and it's kind of like an end goal, probably, to have actually users verify and increase the security of the network with their mobile phones and get rewarded for that. It's like definitely something that we're very interested in. Thanks, great question. Go ahead. Sorry, companies. Sorry.
Company structure. You mentioned how Polygon is sort of like owned by the public, much like a lot of crypto projects are.
Yeah.
But then, like, how does the company go about financing? Like, is there a specific like token supply allocated to the company? And then, are you able to change that over time? So I know this is something that like a lot of crypto companies have to sort of figure out from scratch.
Yeah, that's a great question. So there's no specific company behind Polygon. There is Polygon Foundation. Like similarly to Ethereum, there is Ethereum Foundation, or with other source project like Linux, for example. Linux has Linux Foundation that is supporting the development of that operating system. So there is Polygon Foundation, and when Polygon token was created, a certain portion, roughly 20% of the supply, was committed to the foundation to actually support and develop the whole ecosystem. And because Polygon did, I would say, very good work on development of the application of the platform itself, the dollar amount of those tokens grew exponentially, and Polygon Foundation has a huge war chest at disposal. It's roughly a little bit north of $1 billion at the moment. So it really played out really well. And it's another, how can I say, it's another kind of fascinating thing about these crypto projects, that you can actually fund now open source. Open source was always notoriously kind of hard to fund and hard to monetize. So now everyone's able to benefit. Everyone's able to get a kind of a piece of the platform, or a piece of ownership of the platform. So the foundation has enough tokens to support the development. Developers and contributors are getting tokens. Us as founders are getting also a small share of tokens. Validators are getting tokens. So kind of everyone who participate benefit also financially from the network itself. And that's one of the, as I said, one of the interesting properties of these projects. And I think it's definitely more fair way to build projects and companies. Thank you. Okay, I think that's it. Thank you guys so much.